Have you ever stopped to think about how your favorite app, I don't know, TikTok, Instagram, whatever, actually handles all that text you're constantly feeding it? From your username to that killer comment you just dropped? Well, today we're going to pull back the curtain on the absolute workhorse of Java programming, the string. I mean, seriously, think about it. Every single piece of text you type online, your login, your password, that message you just sent, it has to be managed by the code somehow, right? And in the world of Java, you can bet the answer is almost always this string. So to really get this, here's our game plan. We're going to start with the core idea, then jump into the nitty-gritty of making and comparing strings. After that, we'll open up the developer's toolbox to see how we can shape our text. And to wrap it all up, we'll put it all together in a real-world example. Sound good? Let's do this. All right, first things first. Before we can start doing all the cool stuff, we need to understand what a string actually is. And even more critically, we've got to learn its one single most important rule, a rule you can never, ever break. So what is it, really? Well, at its heart, a string is just a sequence of characters. That's it. Letters, numbers, symbols, even emojis. If you can type it, a string can probably hold it. It's the basic container for pretty much any text in Java. And here it is, the big one, that non-negotiable rule I was talking about. Java strings are immutable. And this isn't just a suggestion, it's a fundamental law of how they work. Understanding this one word, immutable, is going to change how you think about manipulating text. So, what on earth does immutable mean? Well, think of it like this. A string is like writing something down in permanent ink. Once you've written hello, you can't just go back and erase the O to make it hell. No way. If you want to make that change, you have to grab a totally new piece of paper and write the new word from scratch. And that's exactly what Java does. Every time you think you're changing a string, what's really happening is that Java is creating a brand new one in memory. Okay, so we've got it. Strings are these unchangeable bits of text. Now, let's get our hands dirty. How do we actually create them in our code? And, just as important, how do we figure out if two of them are actually the same? Making a string is probably one of the easiest things you can do in Java. Seriously, you just declare a variable of type string, give it a name, like greeting, and set it equal to whatever text you want inside double quotes. And bam, you've just created a string. Now, this next part, this is where so many new developers get tripped up. Let's say you have two different strings. How do you know for sure if they contain the exact same text? It sounds like a simple question, but the answer is a little tricky. This slide right here is absolutely critical. That double equals sign, double equals, it's like asking if two pens are literally the exact same physical pen. It's checking if they are the very same object in your computer's memory. But the dot equals method, totally different. That's like asking if two different pens wrote the exact same word. It doesn't care about the object, it cares about the content. So here's the golden rule. Remember this forever. When you want to know if two strings have the same text inside, you always use dot equals. All right, so we can make strings, we can compare them the right way. Now it's time to open up the toolbox. Let's look at some of the most common and useful methods for just, well, looking at our text and finding out information about it. First up is a true classic. You have a piece of text, and you just need to know how long it is. How many characters are in there. For that, we have the super simple but incredibly useful .length method. So let's say we take the string Java, and we just call .length on it. What do you think we're going to get back? Yup, you got it. 4, J-A-V-A. It's really that simple. A super handy way to find out the size of any text you're working with. Okay, but what if you don't care about the whole string? What if you just want to grab the one character at a specific position? For that, we've got the .charAt method. Let's try it out with the word code. We're asking for the character at index 1. Now, here's a key thing to remember in pretty much all of programming. We almost always start counting from 0. So, if C is at index 0, what's at index 1? It's the letter O. This is so useful when you need to loop through a string and do something with each character, one at a time. So far, we've basically just been looking at our strings, kind of poking them to get info. Now let's get a little more active. We're going to check out some methods that don't just inspect text, but actually create brand new strings based on the original. These two right here are your secret weapons for dealing with messy user input. Think about it. You ask a user for their city, right? They might type New York, or even New York. By just converting everything to, say, lowercase, you can easily check it against your database without worrying about capitalization. Let's see it in action. We've got the string watch out with a mix of cases. Now we're going to hit it with the toLowerCase method. What's going to happen? And there you go. A brand new string is created, all in lowercase. And remember that immutability rule? The original watch out string is totally untouched, safe and sound somewhere else in memory. This is a new one. Oh, and you know when a user accidentally hits the spacebar a couple of extra times before or after they type their name? So annoying. Well, the .trim method is your best friend here. It automatically chops off any of that leading or trailing white space. It's a lifesaver for cleaning up input. Okay, we've looked at a bunch of different tools in our string toolbox. Now, let's see what happens when we chain them together. This is where the real power starts to show. So let's imagine a user is signing up for your app. And this is the username they enter. Look at it. It's a mess, right? We got extra spaces on both ends, some random capital letters. It's just not clean. So what do? First, we call .trim to just shave off all that extra white space. Then, on that new trimmed string, we call .toLowerCase to make the case all uniform. And just like that, you've turned that messy input into a clean, predictable username, user_name. That's called method chaining, and it lets you do some really powerful transformations in just one line of code. All right, so let's do a quick recap of the most important stuff. Number 1, strings are immutable. They can't be changed. Number 2, always use .equals to compare what's inside them, not equals. And finally, you've got a whole toolkit of methods like .length, .trim, and toLowerCase, all of them, to inspect your text and create new, transformed versions of it. Because really, at the end of the day, that's what this is all about. Text is just data. It's raw material. But now you have the tools to shape it, to clean it, to understand it. You can build things that process language, that understand your users, and that turn simple words into meaningful actions. So the only question left is,